Hello and welcome to ABC Splash live events, great big celebration of World Space Week. I'm Bernie Hobbs from ABC Science, and it's so great to have you guys here this Savo to help us celebrate World Space Week, because we've got some incredibly special guests for you here today. I'm a little bit too excited already at just having met them, so forgive me if I go a bit crazy at some stage. Our first guest this afternoon is a real live astronaut, Australia's first astronaut, Dr Peter Scully-Power. Woohoo! I can't hear you. You'll have to yell louder for Peter.
But it's Paul.
Oh, Peter, Paul, your brother went. Paul Scully-Power. Paul Scully-Power. Paul loves correcting things. That's why he became a scientist and went into space. Our other guest is Dr Louise. No, I'm kidding. It's Dr Lisa Harvey-Smith, who's an astrophysicist. So, astronaut, astrophysicist. Any question you've got about space, that's what we're going to be hearing from you today. So send us in your questions, and I'm just going to put your questions straight to our experts first up. Now, Paul, that's a pretty flash jacket that you're wearing there today. Tell us the story of that.
Well, it's standard government issue.
Which government?
US government.
It says NASA all over it.
Right.
Is this the actual jacket that you wore? So you were an astronaut. What did you do?
Right. Well, I went up on the Space Shuttle Challenger very early in the shuttle program.
Like in the 80s?
Yeah, in the early 80s. And
before you were born? After I was born? Yeah.
That's when it was dangerous to go to space, because if you may recall, you can look it up on the internet, in the early launches, the tiles, the protective tiles used to fall off.
Yeah.
So on asset, we lost a lot of tiles. So.
No good.
So yeah, it sort of can spoil the rest of your day. Yeah,
yeah, but you and the jacket survived.
Right. Yeah.
And this jacket has been in space.
No. This is it's like a training jacket.
All right.
No, they tend to control everything that goes to space, because obviously if someone sells it, and you'd have a black market, and so they tend.
We don't want to get into any of that. We've got our first question already, and I haven't even got to ask Lisa about her jacket, which is also very nice, but I don't think it's standard NASA issue.
No, sadly not.
Our first question, Billy asks, how long does it take to get to the moon? Now,
well, with the space shuttle was only designed to sort of orbit the Earth, launch satellites, have environmental sensors that can sense the atmosphere and things like that. Going to the moon takes about 3 days.
3 days. So how far did you get towards the moon?
Very small. It's about 250 miles, 400 kilometres, something like that.
So what did it take you, half an hour?
8.5 minutes.
8.5 minutes? 8.5 minutes. I mean, you're an astronaut, but an 8.5 minute astronaut. Do the other guys tease you for not going to the moon, the other astronauts?
No, I don't think so, because the whole point was that there was a moon program and that stopped.
Oh, yeah, right.
And the whole point of the shuttle program that people miss is the whole point of that program was to build the International Space Station.
Okay, and
now we have it.
Yeah. And that's where it's all going on today. Right. We're going to see some photos from the shuttle a little later on, but we've got some other great questions as well. Lisa, we've got a question from Amelia about planets. Why is Pluto called a dwarf planet?
Oh, that's a good question. There's a bit of ancient history to this.
Yeah.
When I was a youngster.
Longer than 8.5 minutes?
Yeah, longer than 8.5 minutes ago. A few years back, Pluto was a planet for many years, from the 1930s, I think, when it was discovered. And there used to be 9 planets in the solar system. Pluto was the furthest one.
Yeah.
Not always, actually, because its orbit around the sun, the way it spins around the sun, actually moved like in an egg shape instead of a circle. So sometimes it was closer to us than Neptune was.
Right.
And that was one of the reasons, because it was really odd in several ways. It was a very small planet. It had a moon that was almost as big as itself, and it moved in a very funny way.
Well, it would be, because it'd be going crazy with its moon.
Its orbit was kind of an egg shape. It was dancing around a waltz with this huge planet.
Yeah.
The huge moon, and also it was going around in a kind of a wobbly orbit that was a bit diagonal to the plane of the other planets. So in all those ways, it was really unusual, Pluto. So it's actually now been downgraded from a planet. So it got kicked out of the team.
Isn't it just because it's a bit tiny as well?
It's a bit tiny. It's not quite round enough, and it's not quite in the right.
It's like a little potato, a chat potato in space doing a crazy orbit.
That's right. It just doesn't fit in. And we still love it.
Oh, we still love it.
Love it.
Now, Lisa, I want to know, because you haven't got a very special jacket, but I do see something poked down between the chairs there. What have you got there for us today?
Well, I am an astronomer and I use telescopes to measure space, make pictures of space. And I've got a camera from a telescope here.
That does not look much like a camera,
I know.
I have to say. That looks like a
it?
cheap prop from Play School.
That's right. In fact, this is a bit of a prop. The real one is 4 times bigger than this.
Right.
Okay, but this camera is from a radio telescope, so it helps us to see space and make pictures of very, very distant areas of space.
But where's the lens and the shutter and everything?
No, it doesn't have any of that. What it has, we build a huge so-called radio telescope, a dish. It's like a wok.
Yeah.
And we make that out of metal, and that is used to collect the light, just like a bucket would collect water from a river.
Yeah.
And the information from space bounces off that wok and into the middle of the telescope where you put this camera. And this thing converts light into electricity.
So it takes pictures of space.
It takes pictures of space.
So it must be pretty high pixels if it's because space is big.
Yeah. So how many pixels? This isn't a chessboard, by the way.
Is each one of those things a pixel?
Each one of these things is a pixel.
Right.
So each one of these squares on here is 1 pixel. Now the real camera is 4 times bigger than this, and it has 188 pixels. Doesn't sound very good, does it? Doesn't sound very good.
It's got about 8 megapixels.
Exactly. I've actually got one of these little tiny image sensors. This is a camera inside your phone.
Yeah.
Inside the camera is one of these tiny little image sensors, and this has electronics in it that turn light into pictures, into electronic pictures that you can see on your phone. And you can stick them up on the internet or whatever you do with your pictures, share them with your family.
How many pixels in that?
This has 16 million pixels.
16 million
megapixels.
What was this, 128?
188.
188. Sorry to underestimate you there.
But you know why?
What?
Because this one picks up light waves that are 30 times smaller than a human hair.
Right.
So they're tiny.
Yeah.
And the radio waves that these are collecting, so the light is much, much bigger.
Like meters long.
It's like 20 centimetres across, something like that.
Wow.
So one of the waves is much bigger, so the camera has to be a lot bigger to make a good picture.
Fantastic. Look, that's crazy. That's amazing, and thanks for bringing it in.
No worries.
Jacket, telescope, camera. It's hard to say which is best, but I do love them both. Let's get back to some more questions. Paul, what did you eat in space? And follow-up question, how did you brush your teeth afterwards?
Okay. What you eat in space is sort of like what I call a TV dinner. Like it comes prepared and you stick it in a microwave, heat it up and eat it. So it's,
have you got gravity there?
No,
none at all. Okay.
And what you have to be careful of is that, and folks don't really get the point of this, but if you take gravity away, the strongest force, in nature that we understand, is surface tension.
Right.
So you take gravity away, everything revolves around surface tension. So as long as your food is moist, it will sit on a plate and won't float away. If it's all dry, it will float away.
Oh, so that is good. I was thinking The Simpsons got it wrong, because then in that episode where Homer bit on the chip and it kept running away, but chips aren't moist.
Right. So that's the trick with that. Conversely, if you've got any sort of fluid floating around, surface tension makes it form into a perfect sphere.
Could it be that big? Could you have like a ball of water that big?
Absolutely. We used to get orange juice and have a big, big sphere. And if you're very careful, again, at surface tension, you can get a straw and push it carefully through, and then drink the orange juice, and the sphere will shrink around that as you draw the fluid out.
Wow. Did you do it?
Sure. Now, the other thing is about
brushing
the teeth. It's the same sort of concept. You have to just make sure that the water or whatnot doesn't float around, because it will make a big mess, obviously. So you actually...
And there'll be no jacket for you from
Right. So you brush your teeth with a washcloth. You hold the washcloth there and sort of...
okay. So really, as long as what you're trying to do is make sure that any mess is contained and can get cleaned up quickly.
Exactly.
So if you just use a standard toothbrush and paste and everything...
Oh, yeah.
Yep. Easy easy.
Yeah,
How do you brush your teeth over at Epping, where you work, Lisa?
Oh, yeah, just pretty normal, actually.
Pretty normal.
Yeah.
Well, it seems to be working.
Not as good as a space shuttle, unfortunately.
Now, I have to say, Paul, you're also famous, as well as being Australia's first astronaut, first astronaut ever with a beard.
And the only one.
And the only one.
Right.
Does no one else want a beard, or did you have to get special permission?
No, well, in a sense it was special permission because they say that you have to be clean shaven. So I asked them, well, why is that? And, well, it's safety reasons. And I said, I'm a big proponent of safety. Tell me why. Well, it turns out because you have to get a good air seal with your helmet.
All right.
Because A, it affects the oxygen which you have, and B, it affects the communications because you have a leak, you've got the background noise.
Yeah, right.
So I said, I understand all that. And so I said, so that as long as I've got a good oxygen seal and I don't get background noise, is that fine? Anyway, I conned him into that.
You are trouble. He also conned our makeup artist into giving him a free haircut today. So you can get anything that you want pretty much. You're really playing that astronaut card.
So the point is, so they said, okay, we'll give you the test. So they gave me some really tough tests and I passed it. And then I said, okay, so it's not a safety issue anymore. See, what they forgot is that I used to be a Navy diver. So I was a professional at getting seals.
Yeah, right. Okay, seals. That's like a joke.
I'm glad you got it.
Now, Lisa, we've got a question from Ruby for you. And hey, guys, thanks so much for sending your questions in. Keep them coming. Because how often do you get to ask a question of an astronaut and an astrophysicist? It's crazy. Ruby wants to know how close you can go to the sun without dying.
Oh, that's a good question.
It is, isn't it?
I mean, some of the dangerous things about the sun, obviously if you get closer to it, a lot of the radiation gets a lot stronger.
Yeah.
And obviously the sun is actually a ball of gas, and inside is burning by nuclear fusion. So atoms are banging together, creating huge amounts of energy and huge amounts of radiation.
And the radiation you're talking about is all kinds, not just radio.
Yeah,
what's
all sorts. High energy particles called cosmic rays, and they could damage your body. And certainly people in space, you have to have protection, don't you, in spaceships from this kind of radiation.
Right, and you've got to be careful of the Van Allen radiation.
That's right, yeah. So there's all sorts of radiation in space
it's dangerous.
that our atmosphere protects us from.
Yeah.
So the atmosphere sort of absorbs or scatters a lot of this dangerous radiation that's in space and keeps us safe on Earth. So if you get close to the sun, and say on the planet Mercury, that's the closest planet to the sun, there will probably be quite dangerous levels of radiation for humans.
Yeah.
So you don't have to get very close to the sun. It's just the protective layer that the atmosphere provides that keeps us safe from that kind of radiation.
Even once you get out of our atmosphere, you start being in trouble. So you were out of the atmosphere.
Right, it's one of the issues you've got to worry about when we go to Mars is the radiation levels.
So what do you have to like be in a lead tent or something, or what protects you from the radiation?
Yeah, well, they're actually formulating something like a lead tent, but
all right.
high tech, but so their radiation doesn't get to the human body.
Yeah,
so.
Fantastic. Okay, now Paul, year 6. Oh, Paul,
yes?
year 6 butterflies ask. We need a comma there. Does having no gravity wear you out? Do you get tired from not having gravity?
No, and everyone asks that question the wrong way. Okay?
Okay. No offence, butterflies, but I told you he's a tough character.
Think about what you do at night.
Sleep.
Right. Now, what do? You lay down on a bed.
Yeah.
Right, and you put your head on a pillow. Mm-hmm. So why do you put the head on the pillow?
Because it's a bit higher than the rest of your body?
Because it takes the weight off your head.
Ah.
Right. So the question should be, how do you keep awake in space?
How do you keep awake in space? That's a supplementary, yeah. Hey, actually, we've got some photos in the space shuttle that you've brought in for us, and I don't know if these are actual photos of you or photos you took of other astronauts in the space shuttle. So if we could just have a look.
I know, yeah, that was on our mission. 2 of our crew actually, as you say, did a spaceport, went outside, which is...
So that's outside of the space shuttle that we're looking at?
Yeah, that's in the cargo bay. See, there's the 2 main thrusters you can see in the tail sitting.
Yeah.
And you've got to obviously have a pressure suit because space is a vacuum.
Yeah. So everything would get sucked out of you.
And what it does, it will boil your blood in under a second. And if you boil your blood, you have a problem.
Yeah.
So,
hey,
but it's exactly the same as deep sea diving. Big suit, blow it up.
So that's funny because you started as a Navy diver.
Right.
So
it's exactly the same.
Did you want to be an astronaut, or was it just?
No, it just sort of happened.
Yeah, just sort of happened. So you don't have to have a really big, long dream. Now, I don't want to bring this up or sledge NASA at all, but that inside the space shuttle did look a bit like it was brown paper stuck together with bits of tape. Was it really? I mean, look at it. That does not look.
Well, but that's material cladding.
Right. So, not brown paper.
No,
unfortunately. No, okay, well, NASA.
It's not an ABC show.
I'm not. So cheeky. You saw the prop that CSIRO gave Lisa. We're all on budgets, you know, Paul. We're not all ex-NASA. Now, Lisa, Sarah's got a question. How do people know what the universe looks like? Man, that's a fantastic question.
We look at it. It's a serious question.
Yeah.
You know, we have a look with telescopes, and since 300, 400 years ago, since we've had telescopes, we've just been able to see further and further and further out into space, and to see billions and billions of stars and galaxies and all the kinds of things that we've discovered over 1,000 planets, and these telescopes help us to understand what the universe looks like.
Now, I've heard something that there are more stars in the universe than there are grains of sand on the Earth. Is that right?
I've never checked.
I
do go to the beach, but I've never checked. I lost count last time.
Maybe we can get, butterflies from year 6 to start counting sand, and we'll see if we can come up with that. But there are a lot of stars.
There are a lot of stars.
Yeah.
Our sun is the nearest star.
Yeah.
So that's a big star.
Yeah.
And that keeps us warm and safe and grows plants and allows us to live.
Yeah.
And in our galaxy, which is kind of a cosmic village, it has 100,000 million stars.
100,000 million. 100 billion.
Yes.
So more like.
And they're all suns.
It's like it's like 15 times the number of people on the Earth.
Yeah, it's immense. And that's one galaxy. That's one spiraling group of stars.
How many billion galaxies?
At least 100 billion.
At least 100.
Galaxies.
Okay, all right, this is ridiculous.
There's
I think you're making it up now.
Gazillions of stars.
Gazillion,
that's not even a real word.
Yeah, no, that's all right, but you're going along with it, Paul. Gazillions.
Oh, yeah, absolutely. But you can draw an interesting parallel with the internet.
Yeah.
That, you've got an IP address. Everyone has an IP address.
Yeah, so the numbers one with the decimals in between.
Yeah, so on the new internet system that's starting worldwide, it's already started, which is how they track, who's making a phone call and all that.
Yeah.
The incredible thing is there's going to be more IP addresses than there are stars in the universe.
No. Why?
Because that's the way they've designed it.
But there's never going to be enough people to use them.
I understand.
Anyway, that's another show. That'll be World Internet Week. We'll get Paul back and talk about the IP addresses. Now, Paul, another question from you. What did you do for fun in space? So cast your mind back, because it's the 80s. It's a long time ago. But what did you do for fun?
No. Again, it's pretty straightforward. You're actually sent up there to work. So.
All right. But NASA's not down on fun.
No. And so you do what you have to do, but there's always problems, Instrument doesn't work or something. So you're always playing catch-up ball.
Yeah.
So the only time you have to basically, when you're not sleeping, is like when you're having a meal.
Right.
And so you actually look out the window. And that's the big thing.
Oh, because it must be incredible. And in fact, we've got another photo of the view that you can see from the space shuttle. I'm not sure if you took this photo. Well, look, that's...
No, that's the International Space Station.
Oh, that's the International... Well, that wasn't even there when you were up there.
Right, exactly.
Yeah.
And that's what the whole point of the shuttle program was, to build that.
Yeah, fantastic.
And it's been permanently manned since it was built.
Yeah.
So
do you want to go up there?
I wouldn't mind.
Do you reckon you've got a shot?
Yes, but I'm too young.
You're too young. Give it another 10 or 20 years.
No, you've got to be the first. I've got to wait till I'm old enough to be the oldest person in space, you see.
Oh, okay. Oh, so many rules, so many records to set. But I did, while we're on it, I did just want to have a look. There's another photo that's got that's one looking down at a special part of planet Earth from space. If we can see that photo.
And I'm sure,
hang on, does anyone have a guess at what we're looking at? Anyone got an idea of what we can see there? Paul?
Yeah, well, the view from space is, with the naked eye, which is people are surprised, is anything you see here down on Earth, so to speak, is two-dimensional. It's a film, a photograph, a video.
Yeah, right.
But the view from space with the eye-brain combination is three-dimensional. So you can look, and that makes all the difference.
Yeah.
So you can look down, and what you're looking at, if you look carefully at that photograph, if they put it back up, right, a big blob in the right, there's a coastline, there's land on the left and water on the right. That big blob in the middle is Botany Bay. And if you look carefully, you can see the two main strips of Sydney Airport jutting out into Botany Bay.
Fantastic.
So once you've figured that out, you go north of that and you can see Sydney Harbour.
Which is tiny compared to Botany Bay.
Right. And if you look carefully, you can actually, even in that photograph, make out the Sydney Harbour Bridge and the Opera House.
Wow. Okay, not with these eyes.
No,
but you can.
But if you look at it, it's quite.
So if you zoomed in, could you see the number of grains of sand in the picture?
Two birds, one stone. Yeah. I love that. Hey, Lisa, we've got another question for you from Jared.
Cool.
Will it be possible for us to live on Mars when we grow up?
Yes, I think so. If we work hard, yeah.
If we work hard. So what needs to be done?
Well, we know how to get. We've been to the moon. 12 people have been to the moon. We know how to get up into space safely.
Yeah.
We know how to live in space.
Right.
Might be difficult. People might, get on each other's nerves a bit because it takes quite a while to get to Mars. I think it takes about 2 years, does it? Something like that?
It depends on the alignment, but the minimum is 18 months.
18 months.
Alignment like the horoscope. Like no, right?
Yeah, it is like that. Which planet's closer to you and when? Because they all rotate.
Yep.
So the minimum time's 18 months.
Yeah, 18 months. Wow.
Yeah. And then there's been projects. I think it was in Russia where people have lived in these capsules, for 2 years, and it's like Big Brother, sort of, cameras on them. And
I lived in share houses
which I might add, huge problems when you do that.
Yeah.
Yeah. Psychological problems.
Yes.
Yeah.
Did you have was it really hard going? How many people were up there with you?
7.
And for how long?
Including me.
Yeah. How long?
8.5 days. And in those days, that was by far the longest and the biggest crew ever.
Yeah. But were they starting to annoy you?
No. The answer is no, and the reason is subtle. Let's take the studio, for example.
Yeah.
At least 50% of the volume of this studio is never used.
Right. On this set, when Q&A's in here, it gets pretty busy.
No, you can't walk on the ceiling. You can't walk on the walls.
Yeah.
So in a zero-gravity environment, a volume is much bigger in terms of useful space.
So you can get away from them, that's what you're saying.
Right.
You just float away.
Yeah.
Don't like what someone's saying.
Exactly.
Yeah, later.
See ya.
Yeah. Okay, look, we've got all these questions coming in. It's so great. Thanks, guys. Another one for Lisa. What are Saturn's rings made of?
So have you ever looked at Saturn's rings through a telescope?
I have actually, and it's pretty beautiful. Photos are even better for me.
Isn't it just wonderful?